Welcome back to continue our lecture on three-phase power calculations. Today we will do example 2. A balanced three-phase Y-connected generator with a positive sequence has an impedance of 0.2 plus J 0.5 ohms per phase and an internal voltage of 120 volts per phase. The generator feeds a balanced three-phase delta-connected load having an impedance of 118.5 plus J 85.8 ohms per phase. The impedance of the line connecting to the generator to the load is 0.3 plus J 0.9 ohms per phase. The internal voltage of the generator in the A phase is the reference phasor. Calculate the total complex power delivered to the delta-connected load. What percentage of the average power at the sending end of the load is delivered to the load? Since we have solved this problem before, we already know the phase voltage and the phase current. So we will write those first, where V phase is equal to VAB, which equals 202.72 with an angle of 29.04 degrees, and the units are volts. And I phase is equal to IAB, which equals 1.39 with an angle of negative 6.87 degrees. And the units are amps. And notice that these are delta connected values, so these would be at the load. So then the total complex power is equal to 3 times the magnitude of V phase times the magnitude of I phase, where the angle is theta V phi minus theta I phi. So we can write that the total complex power delivered to the load is also can be written as 3 VI conjugate. So that equals 682.56 plus J 494.21 volt amperes in rectangular form, or it can also be written as, which is equal to 842.69 with an angle of 35.91 degrees. And the units are volt amperes. Part B says, what percentage of the average power at the sending end of the line is delivered to the load? So the first thing we should see here is that using this real part of the total power, we note that this value here is actually P load. So Pn is going to equal P loss plus P load. And to find P loss, that would be 3 times the line current magnitude, which is 2.4 squared, times the resistance in the line, which is 0.3, plus 682.56. So Pn is equal to 687.74 watts. So the efficiency is equal to P out over Pn times 100. P load and P out is the same thing. So this is 682.56 divided by 687.74 times 100, and the efficiency is equal to 99.25%.